For the last quiz, there were a couple of questions. One of the questions was about how many isomers have tertiary carbons in them for hexane. So if you look at the hexane isomers, there are 5, and we practiced writing these out in a previous video. This guy has primary and secondary carbons. If you look, any primary carbon is attached to just one other carbon. Any secondary carbon is attached to 2 other carbons. So we have primary, secondary, 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 primary. So 6 carbons are all primary and secondary. Here, this guy is primary, attached to one other carbon. This guy here is our first tertiary carbon. So this carbon is attached to 1, 2, 3 other carbons. So that's tertiary. Okay, here, 1 primary, secondary, tertiary. 1, 2, 3 carbons attached. So tertiary is this one. This one, you might say, looks like it's tertiary if you start thinking about the branches, but this is actually a characterization we have not talked about yet. This carbon is attached to 1, 2, 3, 4 other carbons. So this one is called quaternary. Quaternary means 4, so if it's attached to 4 other carbons. And then the other one that we also didn't talk about is if you just have a methyl group, right, or methane, and there's no carbon attached to this one, this is just considered to be a methyl carbon. It's not even primary because it's not attached to another carbon. So we talked about primary, secondary, and tertiary as more common and more relevant for reactions, because that's when the substituents can be reactive. Quaternary and methyl are other extremes that we haven't talked about. So oftentimes when we cover something, especially in an introductory course, we don't cover everything. We just give you some of the basics to start your understanding, and that'll be expanded on later. And I've been putting a little dot here because clearly this carbon is connected to 1, 2, 3 other carbons. So there's a couple of tertiary carbons on this isomer. So there are 1, 2, 3 isomers with tertiary carbons in it. And that's the answer. The other question that there was some question about is if somebody mistakenly named something 1,1-dimethyl pentane, right, or considered the 1,1-dimethyl pentane isomer, what we would do is to figure out what it should really be is put 5 carbons in a row because that's the pentane, but then we would attach 2 carbons to the first carbon, and what this would do is extend the chain. So that's why 1 substituents on typical alkanes are not generally new isomers. So now we've extended the chain, and that changes the numbering system. So we have 1, 2, 3, 4, 5, 6 carbons in a row. So 1,1-dimethyl pentane doesn't make any sense. Now we have a hexane because we're 6 carbons in a row. And the branch now is off the second carbon, which in this numbering system was the first carbon, but when we extend the chain it becomes the second carbon. That's why this is 2-methyl hexane. So there we go, a couple of quiz answers. Hopefully this is helpful. And if you have any questions, send them to me. I can either post videos or answer by email, whatever works.